All right, everybody, here we are again with another launch. Get everything lined up, and then we'll talk about what we're launching today. And there we go with launch. All right, so let's talk about what we're launching today. Today we are launching two modules, and we will do the math to see exactly how heavy this launch is, because I believe it's a lot heavier than this. May be the heaviest launch that we have done so far, but I'm not 100% sure. Sorry about that. I am back. Okay, so the Japanese. So today we're launching the Japanese experiment module, and we are launching the Columbus Orbital Facility. So, kind of a lot to talk about. So let's get into it. The Japanese experiment module is also nicknamed Kibu, which is translated into hope. It's a Japanese science module, obviously going to the International Space Station, developed by JAXA, or the Japanese Aerospace and Space Exploration Agency. It is the largest single ISS module and is attached to the Harmony module, which was launched yesterday. So if you missed that, go back, and it was in this playlist. It was yesterday, about the same time. The first two pieces of the module were launched on Space Shuttle missions STS-123 and STS-124. The third and final components were launched on STS-127. It consists of six major elements: the pressurized module, the exposed facility, the experiment logistics module pressurized system, the experiment logistics module exposed section, and the Japanese experience module remote manipulator system, and the inner orbit communication system. So there's quite a bit is in this. We do have the exposed facility, also known as the terrace, that is modeled here. I will show that to you when we get to that. We also launched the experiment logistics module on another mission. So STS-123 space shuttle, it was Space Shuttle Endeavour on an assembly mission, another 15-day mission, 250 orbits completed with a crew of 7. Um, what else about this? It was launched on March 11th of 2008. And STS-124 was launched on May 31st, 2008 by Space Shuttle Discovery. So So also on this launch is the Columbus. It's a ISS module, obviously. It's the JAXA or ESA's largest contribution to the station. Also has a external scanning um, module on the outside of it used to measure wind speeds on Earth. And there we go. There's our separation of our upper stage. So we can see on top is the JAXA module, and around the JAXA module we have a experiment. We're going to try to. This is the first time we've launched more than one module at a time, and so um, I wanted to see the best way to do that. So there's obviously a couple ways we could have uh, launch two modules at the same time. The first way we could launch two modules at the same time is dock one and then translate over and dock the other one. However, with this module specifically, we're unable to do that because the exposed facility, which you can see there pointing up, which contains a bunch of science out on it, um, prevents us from attaching that section to our rocket. So we're with only one docking port on this module, we're unable to dock and then translate over. So we have a bunch of um, trusses essentially on the outside of that. Each one of those four can act as an independent space satellite, which they will be jettisoned from. We'll do some little bit of experimenting on them, and they will act as the CubeSats that get launched from the International Space Station quite often during spacewalks. So instead of doing that every time, we're just going to launch four of these, and they will be our CubeSats that get launched from the space station to model that. After we separate the Japanese experiment module and get it docked to the station, to node 2, we will then go back to our upper stage, which will then go and dock the Columbus orbital facility. So let's look and see how heavy our payload is today. So we have an end mass or a dry mass of 9.1 tons, and we know that our upper stage is approximately 5 tons. That's what we've been doing for all of our math, and so we're just going to keep that the same. So today we're launching 4.1 tons. Yesterday, for example, or for reference, our launch weight was 2.4 tons. So not quite double, but nearly twice the weight today as we did yesterday. And you can see that our rocket kind of struggled to get us into a good orbit, which is why we have to perform a little bit different of a burn here to get a good intercept, as our apoapsis right now is 540,000 kilometers and climbing. Those small, what are going to be CubeSats essentially, have the ability to recharge their batteries. They have their own batteries, they have their own communication system, their own probe cores, fuel, reaction control wheels, all the works. So, just like a real CubeSat would have. So here we come with our intercept. Now we need to, our relative velocity is very different. We've got a relative velocity of about 377 meters per second before we started our burn, but we still have plenty of delta V because this upper stage is so amazing. Starting to get close now. Takes a long time to burn when your thrust to weight ratio is less than 0.5. We're 0.55 now, but I don't think we were when we started this burn. And finally, there we go. Oh, messed up there at the end, but that's okay. And we'll point towards the station and perform another burn to bring us in closer. We had turned off our monopropellant and fuel tank so we didn't burn fuel out of our CubeSats, as that would be very bad. Our OMS seems to be a little bit touchy here, overcorrecting a little bit. And we're ready to separate our Japanese module here in just a minute. Here we go. We'll separate the Japanese module. And use those tugger CubeSats, I guess you could call it. Oh, we accidentally left that one turned on. Use some of the monopropellant out of it, but that's alright. And we know we missed one. Oh, there it is. Okay. There we go. Okay, we need to reset our target. Right there. Perfect. And we have no reaction control wheels on this module. I didn't realize that. Or at least the ones in our small sats are not strong enough to correct our trajectory. So it's going to be a little bit more difficult to get a good docking, but with a little patience and effort, we'll get there. Yeah, this is going to take quite a bit of effort. Get a save in case we get all messed up. And we actually don't have a lot of electric charge that we're able to store up on this module either. So we're going to have to make sure that we keep getting our panels facing the sun there so we don't run out of power, because that would be a real bummer. Also, one thing that really had us struggling with this module is I have no way to go backwards. So I, not thinking right, placed those directional RCS thrusters on the back side of the module. I didn't put any on the other side. So as soon as we start accelerating forward, we cannot slow down. And we cannot stop or hit the brakes at all, making this docking extremely difficult. And we took us quite a few tries to get it right. So I could have cut this out, but I decided to go ahead and just leave it in so you could see the amount of frustration that this could potentially cause. Of course, it's not that big of a deal. We just oh, see right there, we start going forward and nobody knows why. Um, no, the way that the RCS thrusters are oriented, as we rotate, we gain forward momentum because those rear thrusters fire. The directional thrusters fire to help us flip around, which gives us forward momentum. So we have to, as we flip around, and ooh, we got a little close to that panel there, those radiators. So as we flip around or try to reorient ourselves, we start going forward. So we can reorient ourselves, but only a little bit, because we'll just keep going faster and faster forward, and obviously that's a problem. Monopropellant's starting to get a little low also. You can see all of our resources up in the upper right hand corner. You see our electric charge, our monopropellant oxidizer, and liquid fuel available to us. Liquid fuel and oxidizer doesn't help us at all right now, but just going to take it nice and slow this time. Or try to. See, we already have a little bit of forward momentum and we cannot stop that. If we flip around to stop that, it'll push us way too far forward. So we'll see if we can just kind of deal with it. See, we reoriented ourselves and started thrusting ourselves forward, and then yeah, we're coming way too fast. So we're gonna go past our target. We'll do a flip around, and we'll try again. I'm confident that we will get there. All right, we'll start our we'll do our flip here. Start slowing down our forward velocity. Hopefully we're back far enough, and we are not. We're not back far enough. Well, maybe if we just float away. Let's see if we can get this lined up. Just keep floating back. Just keep floating back. We got this. You can see the Columbus orbital facility attached to our upper stage still floating down there over on your left part of the screen now, waiting for us to get this docked, which I'm getting less and less confident that we will be able to do, given our handicaps of limited monopropellant and our inability to go backwards. Doesn't look too bad from this angle, but looks a lot worse from the side view. Oh, yep, and rotating around there just pushed us forward, so we'll flip around again. Try it again. We don't have too many more tries, as each one of these flip arounds uses a lot of propellant. But oh, this is looking better. This is looking good. Let's just get adjusted. Keep going back. We want to be very careful with how much forward thrust we give this craft, as we tend to pick up some forward thrust just by maneuvering. Okay, not looking too bad right now. Just get lined up. You can see we've already started moving forward, and we have not told our craft to move forward at all. We do need to reorient this so that exposed facility that you can now see with those experiments is facing the correct direction. Needs to be facing zenith. There we go. Perfect. Coming in. Couple of minor corrections. Oh, and we hit the station. Well, good thing we didn't pull a. Oh, get out! Get away! Get away! Get away! Oof. Almost took out those radiators. Good thing we didn't pull a progress and blow a hole through the station. Although that probably would have ripped a hole through the station, to be honest. But that's okay. That's all right. Okay, we're working with a handicap here because we can't go backwards. So we're just gonna let the station kind of rotate away from us and get lined up again. There we go. Okay, see if we can salvage this, as we only have 46 units of monopropellant left, and we're yep, messed that one up. Well, we'll see if we can get another flip in. Okay, this will definitely be our last chance to get it, as we're down to 30 units of monopropellant. So last time's a charm, right? We are mission critical on fuel. Just come in nice and slow. So far, so good. Not closing too fast. Half a meter a second. We're a little off on our left to right and a little off on our up to down, I think, but we will slowly adjust those. And again, after we get this docked, or I should say if we get this docked on this mission, we will be undocking one of those CubeSats, one of those small sats attached to the side, and then we will be performing a test on them to see how much delta V they have and all sorts of things. And then we will undock the rest of the three, and they will serve as our simulation for the CubeSats that are released by the International Space Station. And we need to reorient just a little bit, get a little rotation in there. And did we get it? We got it. We docked. Yay! Perfect. And get a save because yeah, we're not gonna do that again. Okay, so we're gonna undock one of these. Oh, actually, let's go and dock the Columbus orbital facility, and it goes to the port just opposite on node 2. And now this docking procedure should be much easier than the one we just did, as we do have the ability to hit the brakes, figuratively speaking. And just starting making our way in nice and slow. We're currently facing Nadir, so we need to reorient ourselves. And we are nice and lined up now. So just bring it in nice and slow. Now, luckily, there's not a specific orientation that this module needs to be in because there's nothing specific on the outside, at least in our rendition of it. Oh, got a little off kilter there, but we were able to correct it. And we'll maintain, and there we go. Perfect docking. That was great. Get a quick save again. Awesome. We just do a little time warp there to stop those oscillations because, of course, they can get pretty bad here in Kerbal Space Program. Well, not looking too bad so far. And we are facing the wrong direction with this exposed facility. So we're going to undock this, as stupid as this seems, because as much trouble as it gave us and as little monopropellant we have left. But we are going to undock and reorient and work on getting ourselves back. Oh, come on, don't mess this up. Phew. Okay. Okay. Come on. Come on. There we go. Awesome. Sweet. So get another save. All right. Now we're going to run those experiments on those little CubeSats. So there goes the first one. Oh, that's a pretty good decouple there. And let's see what kind of abilities we have. So RCS works really good. We can reorient ourselves. Now we're nearly out of monopropellant, as you can see. We'll face towards, oh, and we don't have any, oh, it's because these are turned off. Okay, there we go. Let's see, okay. So our center of thrust is a little bit off from our center of mass. As you can see, as we burn our engine, our main engine, we get into a tumble. So the more we burn that engine, the more of a tumble it's going to get into. So the ability of these guys to be able to deorbit themselves is not going to exist. And fortunately slash unfortunately in Kerbal Space Program, one thing that is not modeled is the I was just seeing here if the orbital maneuvering system is able to counteract that thrust. Of course, we're almost out of monopropellant, but so typically these sats, because they're so small, they would deorbit in a couple of years by themselves if they were placed in orbit around the Earth from the International Space Station, about 5 to 10 years. But that is not modeled in Kerbal Space Program, so they will stay in orbit forever unless we go and retrieve them ourselves. So you can see as soon as we run out of monopropellant that it starts to spin. Um, but that's all right. All right, let's go ahead and undock the rest of them. There's 3 more to undock, and they will be our CubeSat analog. Decouple. That really makes the station shake. Decouple. Whew. And please don't hit my solar panels. Decouple, and we're good. We're clear. Perfect. Well, thank you for watching. Remember to tune in tomorrow for more construction. And if you missed yesterday, go back and watch the yesterday video. So all we're doing now is decoupling our upper stage, doing a maneuver to get away from the station, and a deorbit. Just going to end the video after we finish this deorbit, just to prove that we didn't leave it up here in orbit. And there we go. So thank you for watching, and we will see you next time.